Okay, so the question asks to determine whether or not the vector field is conservative, and if it is, to find a function f whose gradient is the vector field. So first, to test if the vector field is conservative or not, we know that P is the I component, which is e to the x sine y, and Q is e to the x cosine y. We perform the test because the theory says if it turns out that the partial derivative of P with respect to y is the same thing as is equal to the partial derivative of Q with respect to x, then it would be conservative. So let's see if that is true. So we will take the partial derivative of P with respect to y, and that is, we fix x and we differentiate with respect to y. So this will be e to the x cosine y, and dq over dx. Here we differentiate with respect to x and we fix y, so we hold y constant. So we would get e to the x cosine y. And indeed, they are the same, so therefore f is conservative. Having discovered that f is conservative, it turns out that if f is to be the gradient of some function f, then the partial derivative of that potential function with respect to x has to equal the p, or the x component of the vector field, which is e to the x sine y. And if I need to take this back, I can differentiate this, because fx means df over dx is equal to e to the x sine y, and I can turn this around and differentiate and integrate with respect to x in order to I could just move this dx here, and I can integrate both sides, and of course integral and the derivative go away, and so I would get f to equal, so I would hold y fixed, so this would just be sine y integral of e to the x is e to the x, plus my constant of integration here is going to be some function of y, which I'm not sure about at this point, but it has to be a function of y, since we are dealing with an x and y dependency. Now the objective is to find h of y, so I will go ahead and differentiate this with respect to y. So this will be cosine y, I hold x fixed, so this will just be e to the x plus h prime of y, which, if true, will have to be equivalent and the same thing as the y component of the vector field, which is e to the x cosine y. And we can see that those two terms are the same on both sides, they go away, which tell us that h prime of y is basically equals 0. If the derivative with respect to y is 0, that just means that h of y is constant, some constant k. And so now I can just plug that back into my f, and I would have found a function, lowercase f, whose gradient is identical to the vector field, since it turned out that f is conservative. That guarantees the presence of this lowercase f, whose potential is that conservative field. And what I did is I have just found out what that is. So the final answer would be f equal sine y e to the x. Plus some constant k. That concludes this problem. Feel free to comment, like, and subscribe. Thanks.